Alrighty, guys. So we are going to discuss slope and graphing linear equations. Now, in order to be able to discuss this, we first need to find what slope means within this context, okay? Now, remember the variable we use for slope to represent slope is the variable m. And so, let me make sure this is on. Yes, that is on. Okay, we use the variable m, which stands for, okay, the reason we use the m is because it's from the French term monter. Yeah, I bet you guys didn't know that, right? Okay, so guys, slope represents a change in the vertical. Vertical is the y-axis, over a change in the horizontal, which represents the x-axis. I'm using y for the vertical and x for the horizontal, okay? Now, the symbol we use for change is delta, okay? We use delta to represent change. So another way you could express the slope is delta y over delta x. When you get to calculus, you will see it as dy over dx. Yes. Tangent is also slope, guys. You know, the ratio of y over x, sine over cosine. Yeah, all of that represents slope. So guys, when we talk about slope, you guys commonly refer to it, especially when you're graphing, as a, oh, Shazam, let's go back on that one because I wrote the wrong thing. A rise, again, indicating the vertical change, over a run, indicating the horizontal change. So having said that, guys, remember it's a change. In order to have change, you must compare two things. You must have a starting point and an end point. So if we're talking about slope, let's say we have point A located over here, which is at x1. X1, ooh, maybe not. My pen refuses to write, guys. So let's try this one more time, okay? Let's try it over here in the middle, all right? Let's say this is point A at x1, y1. And this is point B over here at x2, y2. In order to have change, okay, we must compare two things. So first, to calculate the slope, guys, we're going to compare the vertical change. Vertical has to do with the y. So you've got a y1 and a y2. So here at the bottom, we are at y1, and we're going to travel to y2. So the change involves, what is the distance? How many units are going to travel going from y1 to y2? In order to calculate that, we would have to take where we end up at minus where we started. And then same thing with the horizontal change. You're going from x1 right here over here to x2. So if you're doing that, you're traveling from x1 to x2, how many units are you going to travel? To calculate the number of units, you're going to do x2 minus x1. By the way, when you're calculating the slope, guys, as long as you're consistent, you don't necessarily have to do it in this sequence. You could have done y1 minus y2, x1 minus x2. It really doesn't matter. But the bottom line is you can do slope, guys, without memorizing a formula. You can do it, guys, okay, organically. I like doing it organically, people, okay? So I'm going to give you a quick example of this. What do I mean by doing this organically? Let's say point A is located over here at, let me see, 10, 2, 7, negative 10. Okay, I'm just making this up as I go along. So, all right, so let's pretend, guys. We're gonna pretend. All right, right here is 7, negative 10. Okay, I'm just making this up. And then up to this point right here, which is point B at 10, 2. Okay, 10, 2. And then 7, negative 10, okay? So we have to figure out the slope of this line AB, or this segment AB. To calculate the slope, we're going to look at the vertical change over the horizontal change. Remember, the vertical change has to do with the y values. The horizontal change has to do with the x values. At this point, guys, x is 7. And then at this point over here, x is at 10. For the horizontal change, you're traveling from 7 to 10. Just think about it. If you travel from 7 to 10, how many units would you travel going from 7 to 10? You would travel 3 units. Oops, wait a minute. I meant to put the 3 there, okay? 3 units down here, okay? I'm doing it against the figure, and then I'll go ahead and plug it in. Now, on the vertical, guys, you're down here at -10, and then you're going to travel up to +2. So you're at -10, travel up to +2. Now, let's think about this. If we're at -10, and we are going to travel up to +2, guys, how many units would we go from -10 to +2? How many units would we have to go up to get to +2 along the y-axis? We would have to travel a total of 12 units, okay? Just like that, guys. That's common sense. You do not need a formula for that. I want you guys to do this organically. That's why I'm doing this first example without the formula so you guys can see it. So essentially, the 12 represents your vertical change. The 3 represents your horizontal change. And you have a fraction here. All fractions must be reduced. So there's your answer. Now, for those of you who aren't comfortable with this, okay, obviously we're going to practice a little bit more in class. Okay, how about this? So let's label the points. The first point is x1, y1. The second point is x2, y2. So we go into the formula and plug them into the slope formula, guys. And listen, all I'm doing here is proving that we're going to get the same answer, because it really doesn't matter which way you do this, guys. You will always get the same answer. So y2 is 2, y1 is -10. All right. And then x2 is 10, y1 is 7. 2 minus a -10, that's 2 plus 10, that's 12. 10 minus 7 is 3. And guys, lo and behold, 12 divided by 3 is the exact same thing we had before, so we end up with 4. Look at that. Whether you use the formula or you use just good old-fashioned common sense, guys, you arrive at the same answer. Now, there are 4 cases for the slope, guys. 4 cases, all right? When we talk about the slope, we look at positive slope, which is very common. And a positive slope, when you draw a graph, by the way, you go from left to right, left to right. Whenever you're drawing, you're going from left to right. So if we were to give a description to this graph, we'd say that this graph increases, it increases left to right. But what you guys commonly hear is this: it rises, okay? Maybe I'm not getting rises in there. Rises right, and that's perfectly acceptable. Rises right, okay? That means it's increasing from left to right. Now, here's the second case, guys. In the second case is a negative slope, and this is a very common graph too. Again, going from left to right, when it's a negative slope, the graph, okay, if you give it a description, decreases, it decreases from left to right. Left to right, it's decreasing. Now, of course, commonly you guys hear it as this: falls to the right. And there's nothing with that, guys. That's fine. So positive slope increases, negative slope decreases. By the way, guys, I forgot to mention this when we talk about slope, okay? Other terms that could mean slope: the grade or gradient of a road, the grade or gradient of a road, how steep is that road? The pitch of a roof, okay? The pitch of a roof, the grade, all of those guys have to do with slope. Now, of course, we use slope in various situations. Obviously, when we talk about this in the classroom, we'll go ahead and look at some additional situations like average rate of change. Guys, there's so many instances where we use slope, okay? So anyways, we're gonna keep going, guys. Here is the third case for slope. Now, be careful with this one. When we have zero slope, think of the slope, guys. Remember, it's the change in y over change in x. When the slope is 0, what it's saying is that there's 0 vertical change, but there is horizontal change if we reference the horizontal change as 4. Okay, let's think about it. So if there's 0 vertical change, as in the graph is not moving up and down, but there's movement left to right, what kind of graph would you end up with? You would end up with a horizontal line. Here, let me write this down for you. Horizontal line, horizontal. You need to know these things, guys. Horizontal line. And when we talk about a horizontal line, it intersects the y-axis. So the equation would be in the form of y equals to some value. Okay. So once again, if the slope is 0, this means that you're going to end up with a horizontal line because there's no vertical change, there's only horizontal change. And because it's intersecting the y-axis, the equation would be y equals to b. Now, let's move on. Here comes the second scenario, guys. Now, for the second case, let's think about it. We're still talking about slope. What if instead, guys, the slope was 4 over 0? The 0 was in the denominator. In this instance right here, this is telling you that the graph is moving up and down vertically, but it's not moving left and right as in horizontally. So you would end up with a graph like this. Now, this graph over here, okay, because it's moving up and down, you would think about it in terms of, can somebody go straight up vertical? No, that is impossible. So when the 0's in the denominator, guys, we refer to this as undefined. So this, the fourth case for the slope, the fourth type of slope is when the slope is undefined. There's vertical change, no horizontal change. By the way, guys, this is referred to as a vertical line. And because a vertical line intersects the x-axis, when you write the equation of a vertical line, it's going to be in the form of x equals to a, okay? So when you write the equation of a vertical line, it's going to be in the form of x equals to some value. So those are the 4 basic cases for the slope, guys. I needed to mention that. And then we're going to get to the graphing. Now, when it comes to graphing linear equations, most of you are very comfortable with graphing linear equations, and there's one method that you guys really like. I am going to address 2 very efficient methods. One of them you're very comfortable with, maybe not so with the other one, okay? So here's the first, you know what, before I talk about the first method, let's talk about the T-chart, the T-table, where you are given an equation like y equals to 2x minus 3, and the question comes up, graph this. Let's say you had no clue how to graph this, guys. You can always go back to a T-chart, T-table, table of values, create a few points on the graph, and then go ahead and graph the equation. So what you do is you select some arbitrary values for x, like -1, 0, 1, 2. Plug them into the equation one at a time. So if x is equal to -1, that would be 2 times -1 minus 3, which gives you -2 minus 3, so you get -5. When x is -1, y is -5. Now, if x is 0, 2 times 0 minus 3, this cancels out, leaving you with -3. So when x is 0, y is -3. Likewise, if we do the 1, 2 times 1 minus 3 gives you 2 minus 3, which is -1. So when x is 1, y is -1. And then last but not least, if x is 2, all right, 2 times 2 is 4, 4 minus 3 gives you 1. Okay, guys, so now you have a whole bunch of points on the graph of this equation. Essentially, you're ready to graph it, guys. So I forgot to mention this, but let me go ahead and say it, because you're going to be graphing a whole lot in Math Excel. 2 points determine a line. So when you're graphing in Math Excel, guys, guess how many points you need to graph? 2 points. 2 points determine a line. So you need to have 2 points to graph. If you don't have 2 points, guys, you cannot graph these equations, okay? So I'm going to just go ahead and sketch out a quick graph for you by plotting these points. Now, guys, listen, this is not the best method. Obviously, it's time consuming. So I am going to show you something that's a little bit more efficient, okay? So guys, here's your XY plane. I'm just gonna go and grab 2 out of the 4 points. You can grab more if you want to, doesn't matter. I'm gonna do the 0, -3, which is right here. So that's that one. And I'm going to do a 1, comma, -1, which is right there. 2 points determine a line. You have your 2 points. Just go ahead and sketch your graph. By the way, if you wanted to plot additional points, you could. Like the 2, comma, 1. 2, comma, 1, guys, would be right about here. You know, maybe I missed it just slightly. All right, guys. So that's it for that one there, okay? I didn't want to emphasize this one, but I just needed to mention it. But here's the 2 effective methods used to graph linear equations. Number 1, X and Y intercepts. Guys, this is very effective, X and Y intercepts. Now, when using the XY intercept, it's best to write your equations in standard form. And standard form is AX plus BY equals to C. So write your equations in standard form. Make sure they look like this, guys. Now, listen, everybody. The X-intercept, oh, okay. Yeah, there's a scratch on the screen there. Okay, the X-intercept is where a graph, oh, I got to remember this terminology too, intersects the x-axis. Now, guys, couple of things. As a coordinate point, the x-intercept will be some value, comma, 0. So when you're finding it, to find the x-intercept, let y equal to 0 and solve for x. So you plug in 0 for y and solve for x, guys. That's how you do it. Now, additionally, what I was looking through the assignments, guys, they don't call it the x-intercept. Shazam, I don't know why this program doesn't. They call it the horizontal intercept, which is the same thing as the x-intercept. I don't know why they're doing this, but that's what they're calling it, guys, okay? So just remember that when you see horizontal intercept, they're talking about the x-intercept. Now, let's go to the y-intercept. For the y-intercept, guys, this is where a graph intersects, the y-axis. And as I just mentioned, since they don't call it the y-intercept in Math Excel, okay, in this particular version of Math Excel, they refer to it, guys, as the vertical intercept. So be careful with that. Vertical intercept, y-intercept, same thing, okay? So be careful. Now, the y-intercept is where a graph intersects the y-axis, guys. So since it's where the graph is intersecting the y-axis, listen, guys, when you write this as a coordinate point, it's going to be in the form of 0, comma, some y value. Now, basically, to find it, you let x equal to 0 and solve for y. In other words, you want to go ahead and plug in 0 for x, solve for y. And that's it. That's what you're doing, okay? Now, guys, remember 2 points determine a line. So if you're using x, y-intercept, look, you have your x-intercept, that's 1 point. You have your y-intercept, that's 2 points, and you're ready to graph. Just plot them on the xy plane. So there's no better way to show this than through some examples, guys. So let me go ahead and show you some examples. Example number 1, 2x minus 5y is equal to 10. So this equation is nicely set up in standard form. So you're ready to find your x-intercept. To find your x-intercept, you're going to plug in 0 for y into the equation. So this cancels out, leaving you with 2x equals to 10. So you divide both sides by 2. So x is equal to 5. Now remember, you have to write this as a coordinate point. You put in 0, you substitute 0 for y, solve for x. So your coordinate point is 5, 0. Now let's go ahead and find the y value. For the y-intercept, guys, you are going to substitute 0 in for x. So that's 2 times 0 minus 5y equals to 10. Now, this cancels out, leaving you with negative 5y equals to 10. You divide both sides by negative 5, and bam, just like that, guys, you have your y-intercept, which is -2. Now remember, you have to write this as a coordinate point, guys. You plugged in 0 for x, and you came out with a -2. So you got 1, 2 points. You're ready to graph your equation, okay? Now, I'm going to try and squeeze it down here, guys, okay? This is not a really great place to stick a graph, but we're going to stick it because I don't want to erase all of this. I want the information here. So guys, here it is. I am just going to go ahead and go to the x-axis, find where x is 5. That's right there. Go to the y-axis, find where y is at -2, right there. I plot my points. And guys, 2 points to turn them in a line. Since I have my 2 points, I'm ready to sketch my graph. It's that easy. I like putting arrows at the end, guys. Now notice I'm not putting numbers on the hash marks on the x and y axis because, guys, it's really not necessary, okay? Get to the point, sugar plums, all right? Now, I am going to go ahead and clear this one out, and I am going to do a couple more examples with you guys. And then I will show you the x and y intercept. The slope-intercept form, guys, okay? So here comes another one, guys. Let's say you have 2x plus y equals to 4. Now, listen and listen well, sweetie pies, okay? When we're finding the x-intercept, okay, this is like saying the y variable doesn't exist, okay? This is like saying this term is not there. If I was in a classroom with you, I would say this is called the cover-up method, but I can't cover it up right here. That's why I erased it. So guys, what do you see you have left over? 2x equals to 4. So then that means that 2 times what gives you 4? That means that x has to be 2. So if x is 2, okay, you plugged in 0 for y, x is 2, you have your coordinate point, 2, 0. Now we're gonna do the same thing, guys. Ooh, Shazam. You know what? Hold on a second. Let me put this back first. And then, oops, I will go ahead and write my point as 2, 0. Now, what if we're finding the y-intercept? If we're finding the y-intercept, guys, remember this time we're plugging in 0 for x. So if we plug in 0 for x, that's like saying this term doesn't exist. What do you notice is left over? Y is equal to 4. So if y is equal to 4, guys, that's your y-intercept. You don't have to do anything else to this to solve it. That's your y-intercept. So your y-intercept for this one is going to be +4 when x is equal to 0. In the classroom, I would refer to it as the cover-up method. When I show it to you in the classroom, I will be using the cover-up method too. But guys, for now, listen, this is just like the cover-up method, but I'm erasing instead of covering, okay? You got your 2 points. 1 point, 2 points, okay? So you're ready to go ahead and graph. So you go to the XY plane, guys, okay? You find where y is equal to 4, plot your point. Find where x is 2, plot your point, and then draw your graph just like that, sugar plums. You're done. Easy. That was the second example. Now let me do a third one. Okay, so let's get it a little bit more challenging. Let's say you have x over 2 plus y over 3 is equal to 1. Yeah, I have to make it challenging. Hello. Okay, so on this one right here, guys, if we're looking for x-intercept, we're going to plug in 0 for y and solve for x. So when we plug in that 0 for y, that's like saying this term doesn't exist. X over 2 equals to 1. What number divided by 2 gives you 1? What number divided by 2 gives you 1? That would be 2. Okay, so then your x-intercept is just 2, guys, just 2. Now let's find the y-intercept. For the y-intercept, very similar. You're going to plug in 0 for x and then solve for y. So again, that's like saying the x term is not there. So you're left with y over 3 equals to 1. What number divided by 3 gives you 1? That's the question. And the answer would have to be 3, guys. So now you have your intercepts. You're ready to graph. So you go to the XY plane, find where x is 2, bam. Find where y is 3, bam. And then draw your graph. And just like that, we're done. Yep. Okay. That's the x and the y intercept, guys. Very easy. Now, you know, on a side note, let me give you these 2 problems quickly. And I'm just going to ask you to find the y-intercept because the y-intercept is critical, guys. Y-intercept, when it comes to graphing, regardless of what method you're using, you got to find it. So here's two quick examples. Y is equal to x squared minus 2. I ask you to find the y-intercept. What would you do? Plug in 0 for x and then work it out. This cancels out, so y is equal to negative 2. Okay, so this one would be 0, negative 2. What about this one right here? Y equals to the absolute value of x plus 2. If I ask you to find the y-intercept, you plug in 0 for x and then work it out. This cancels, leaving you with y equals to 2. So this one would have a y-intercept of 0, 2. So essentially what I'm telling you guys, it's very easy to find the y-intercept. Whenever you plug in 0, guys, into an equation, into a function, what you're essentially finding is the y-intercept, okay? It's that easy. All right, guys, so now I'm ready to move on to the second method, which is the slope-intercept method. And the slope-intercept method uses a formula. And this is the one that you guys are very comfortable with, method number 2. The slope-intercept method is y equal mx plus b. Of course, when you're using this method, you have to rewrite the equation in y equal mx plus b form. Rewrite it in y equal mx plus b form. Once you have it in this form, guys, the first thing you need to do, identify the y-intercept. Find the y-intercept. Number 1, what's the y-intercept? The y-intercept, by the way, guys, is the b value. And you need to write it as a coordinate point. As a coordinate point, remember, you plug in 0 for x. If you plug in that 0 for x, what are you left with? The b value. That's how you get that y-intercept, guys, okay? So let me go ahead and plug that back in there. So 0b would represent your y-intercept. Now, this would be your first point. You need a second point. Now you're going to use the slope to sketch a second point. To sketch a second point, to find a second point. I should have just written out the number. Okay, so guys, the slope is the m value. Remember, the m value needs to be in the form of rise over run. So in other words, it needs to be a fraction. If it's not a fraction, you need to change it into a fraction. So once again, you're going to use the slope, rise over run, to find a second point. Once you find your second point, the last step, guys, is to go ahead and draw your graph. Just draw your graph, okay? But you must make sure your equation is in the form of y equal mx plus b. Okay, guys, so I'm going to start with an easy one, easy problem. So for this one, I've got y equals to 2x minus 1. Okay, easy problem. So first, I'm going to find my y-intercept. What's my y-intercept? I'm going to plug in 0 for x. Okay, Coverup method. So I'm going to get negative 1. Okay, now if you didn't see that, all I'm doing is this, guys. I plug in 0 for x. I'm left with y equals to negative 1. Okay, that's it. So that's my x-intercept. Now the slope. The slope, guys, is the coefficient of x, the number in front of x. So the slope for this one is going to be 2. But remember, it needs to be in fraction form so you can have rise over run. So I'm putting it in fraction form by putting the 2 over 1. So the slope is positive, which means from the y-intercept, I'm going to go up 2 units, right 1 unit, plot my point. Up 2 units, right 1 unit, plot my second point. So guys, let's do this, okay? We're going to go to the xy plane. And we're going to draw this graph, okay? So guys, here it goes. Let me grab a different color, okay? My y-intercept, 0, negative 1, okay? I'm going to go up 2 from the negative 1. So 1, 2, and then right 1 and plot my point. Did you guys see that? Yeah, So I went up 1, 2, right 1, plot my point, and I have my 2 points, so I'm ready to sketch my graph, just like that. Done. Okay, so guys, here comes another one. Okay, now this one right here, listen, be careful with it because first, it's going to be in function notation. Second, there's a negative fraction. F of x equals to negative 1/3 x minus 2. When it's a function notation like that, remember we talked about function notation. This is the same thing as y equals to negative 1/3 x. So it really doesn't matter. First, your y-intercept, guys, is going to be at 0, negative 2. And then your slope is going to be -1/3. Now, when the slope is a negative, that doesn't mean that both the numerator and denominator is negative. The ideal thing to do, guys, it's best to, the safest thing to do, make the numerator a negative. So if your slope is a negative, in this case, -1/3, you would go down. That's the negative, okay? So you would go down 1 unit from the y-intercept, and the 3 in the denominator is positive, so you would move right 3 units. So from the y-intercept, you go down 1, and then move to the right 3. That's how you do the negative slope, okay? You can also do it in reverse, guys, okay? I'll show you in a minute. So I'm gonna go to the XY plane again, and I'm gonna graph this one on the XY plane, guys. I'm gonna show you, okay? So right here, guys, I'm gonna start with my slope. My y-intercept at 0, -2. Oops, let's use a different color. Now, the slope says go down 1, okay, move down 1 over to the right 3. So I'm going to down 1 over to the right 1, 2, 3, plot my second point, okay? But what if I didn't have enough room to travel down 1 unit, move to the right 3 units? I can do it in reverse, guys. I can go up 1 and then move to the left 1, 2, 3 units and plot my point here. See, my graph is still on the same trajectory as the other 2 points. So guys, it really doesn't matter. So this is what the graph looks like. And just like that, we're done. Okay. Now remember, we're going to do additional examples in class. So guys, one last one. And then I'm going to look at 2 of the linear graphs, 2 more graphs with you, and then I'll go ahead and be done. Okay. 2x minus 5y is equal to 10. Now, for this particular problem, what you will notice is it's not in y equal mx plus b form. So that's your first step. Rewrite it in y equal mx plus b form. Solve for y, okay? So I'm going to take my 2x, guys, I'm going to move it over. So this will become -5y equals to -2x plus 10. And then I'm going to divide both sides by -5. Every term by -5. Every term, I'm trying to write a -5 here, guys, okay? -5. Every term divided by -5. There's a negative in there somewhere. All right. And then we're going to simplify this. We get y equals 2. 2 fits because a negative divided by a negative is a positive. 2 fits x minus 2. Now, it's in slope-intercept form. So your y-intercept is going to be 0, -2. Your slope is going to be 2 fits. So guys, now we're ready to go ahead and graph this, okay? So we're going to go to the XY plane. By the way, on this one right here, guys, the slope, it's positive. So it's telling us to go up 2 units and then right 5 units. Ooh, I'm supposed to go right 5 units. That's not going to be sufficient space. I'm going to squeeze it in there, guys, okay? Yes, I'm going to squeeze it in there, all right? So guys, 0, -2, right here, sugar plums, okay? And then from there, we're going to travel up 1, 2 units and then move to the right 1, 2, 3, 4, 5 units. Bam! There's your graph. I don't know if you guys noticed. We did this problem earlier. Okay. All right. So guys, here comes the last 2 cases, and I call these ambiguous cases. And why am I calling them ambiguous, guys? Look at the state of these equations right here that we have to graph. What happens when you get something like this, guys? X is equal to -3 and you have to graph it. First thing you notice, there's no X. So there's no reason for this graph to be intersecting the, oh, Shazam, no Y. Ooh, let me erase that quickly. No Y. Ooh, did you guys see that? Shame on me. Okay, maybe it's getting too late. Okay, my brain is turning to mush. All right, guys, so no Y's here, no Y's, okay? So since the equation has no Y, the equation has no business, the graph of this equation has no business intersecting the Y-axis. So the big question is, how do you draw your graph so it doesn't intersect the Y-axis? Okay, so to draw that graph so it never intersects the Y-axis, guys, you gotta make sure you draw it vertical. So it only intersects which axis? The x-axis. So you go to the x-axis, find -3, bam, draw your vertical line. Done. Just like that. Just like that. Vertical line through the x-axis at -3. And what's the slope of a vertical line? Undefined, guys. Okay? And then last problem, and I'm done. Okay? Now let's get this one right here, guys. F of x is equal to 3 sugar plums. Okay? Now, what do you know about f of x? Oh, that's y sugar plum. What's the first thing you notice about this equation now? Oh, there's no x sugar plum. There's no x. So this graph has no business intersecting the x-axis. So how do you draw it so it doesn't intersect the x-axis? Well, guys, you have to make sure when you go to graph this one, you go on the y-axis, you draw a horizontal line so that it never intersects the x-axis. So you draw a horizontal line through y equals to 3. So it's going to run parallel to the x-axis. So it will never intersect the x-axis. It's a horizontal line, guys. There's no vertical change. There's 0 vertical change, but the graph is moving left and right. So what's the slope? Slope is 0, sugar plums. Yes. And just like that, guys, we're done with graphing. Hopefully you learned something new. Okay, I'm looking forward to going over these problems with you in class, but for now, I'm done. Bye.